Okay, we've examined the situation where we can find the maximum total economic profit, but how about thinking in terms of averages? Average economic profit, as indicated here, the pi stands for profit. Average economic profit is simply the difference between average revenue and average total cost. So the revenue per unit minus the cost per unit gives you the profit per unit. And we know that average revenue, from the perspective of the consumer, is the price that they pay. So we can equally say that the price per unit minus the average cost per unit tells us the average profit per unit. Here we've got a graph showing the average cost, average total cost curve. We can see average total cost falls, reaches a minimum point, and then average total cost starts to rise. And let's say we're talking about a price taker, so this firm's average revenue, which is equal to the price, is in this example fixed at $350. So at every level of output, the price or average revenue is $350. Now at the initial levels of output, 1, 2, 3, 4, we can see that the average cost is greater than the average revenue. In other words, we would say that the firm's making an average loss, a loss per unit of output, at each level of output up to 6 units of output. At that point, we can see that the average revenue is equal to the average cost. So the firm would be breaking even at that point. It would be making 0 average profit per unit. But beyond that, we can see that the average revenue is greater than the average cost at each of these levels of output. Our question then is, at what level of output is total profit maximized? You know it's got to be around here somewhere, but where exactly? Fortunately, before we get to that, what if we were talking about a price maker? In the case of a price maker, we'll remember that in order for the firm to sell more output, it has to charge lower prices, and therefore its average revenue will be lower at each higher level of output. Remember, this average revenue curve is effectively the firm's personal demand curve, and it reflects the law of demand. Again, we can see that there are certain levels of output, very low levels of output, where the average cost is greater than the average revenue, and at high levels of output here we've got the average costs are greater than the average revenue. So it would make a loss per unit at low levels of output here, and it would make a loss at high levels of output. But in between that, we can see that the average revenue, the revenue per unit, is greater than the average cost, the cost per unit, this area in here. Again, our question is, at what level of output would the firm be maximizing its profits? Not its average profit, its total profit. So, fortunately, we've got a rule which we can call the equi-marginal principle, which enables us to determine what the optimal output for the firm will be. And that rule states that the firm should produce more whilst ever the revenue from an additional unit of output is greater than the cost of producing an additional unit of output. Or in other words, the firm should produce more whilst ever the marginal revenue from the next unit of output is greater than the marginal cost of producing that next unit of output, except where it would be rational to shut down instead. So let's go back to our price taker. So we've got a horizontal average revenue curve, and therefore, you'll remember, a similarly horizontal marginal revenue curve. Now our rule says, our equi-marginal principle says, keep producing more whilst ever the marginal cost is less than the marginal revenue, or when the marginal revenue is greater than the marginal cost. So the marginal revenue, the revenue from the fourth unit, is greater than the cost of producing the fourth unit. So it should definitely produce that unit. And here the marginal revenue is greater than the marginal cost. So it would definitely produce that unit too. What about the seventh unit? The marginal revenue is greater than the marginal cost, so yes. What about 8.5 units? The marginal revenue is greater than the marginal cost, and so on. All the way up to here. At this point, the marginal revenue just equals the marginal cost. So at this point we would say this is the optimal output for our firm. Where marginal revenue equals marginal cost, we have the profit maximizing output, which happens to be 11.8 units of output. Just as a side note, if a firm for some reason or other can't produce fractions of a unit, then you should get as close as possible to the point where marginal revenue equals marginal cost. So the marginal revenue will be slightly greater than the marginal cost. So in this case, if that was the case, then we'd be producing at this point here. But we're going to assume we're producing at 11.8 units of output. So, at that optimal output, what is the average revenue or price per unit at 11.8 units of output? Well, we know that it's fixed at $350. Our next question, however, is what is, at that 11.8 units of output, what is the average cost? What is the cost per unit of 11.8 units of output? Well, that's given by the average cost curve. And that is $294. So, at 11.8 units of output, the average revenue is $350 and the average cost is $294. So the profit per unit, the average profit, is $56 per unit. Now all we have to do is work out what's the total profit going to be. Well, that's easy. Total profit is the average profit, the profit per unit, times the number of units produced. We know that the average profit is $56, we just worked that out, times the output produced, which is 11.8. So that's a total profit of $661. And that is the maximum profit being made, that can be made in this situation. The firm is maximizing its profit. At every other level of output, the firm will make less profit than that. Assume we've got a price maker, so we've got a downward sloping average revenue curve, or demand curve. And because the average revenue curve is downward sloping, we know from a previous video that the marginal revenue curve will also be downward sloping. We will have double the slope, be twice as steep. But again, we apply our equi-marginal principle to find the optimal output. What's the best output, the profit maximizing output for our firm? And that is, keep producing while ever the marginal revenue is greater than the marginal cost. So here we can see marginal revenue greater than marginal cost. Marginal revenue greater than marginal cost. Marginal revenue greater than marginal cost. Marginal revenue. up to this point here. This point, the marginal revenue equals the marginal cost. So we know that this is the optimal output for our profit maximizing firm. 6.9. Alright, so the optimal output 6.9. What's the price that's going to be charged at 6.9 units of output? Well, that's given by the demand curve, or the average revenue curve. That turns out to be $465 per unit. That's the price, or average revenue. What is the average cost per unit? Well, that's given by the average cost curve, the purple line, at this level of output, which is, as it turns out, $330 per unit. So we know that the profit per unit is $135. Our question, however, is what's the total profit being generated at that optimal output of 6.9? So again, total profit equals the average profit, the profit per unit, times the number of units sold. And we've got all that information there. The profit per unit is $135, and the output produced is 6.9 units. So the total profit is $932. Easy peasy lemon squeezy.